In this video, we're going to discuss the nomenclature of aromatic compounds. So aromatic compounds have been around for quite a while, and many of them were discovered before the IUPAC system came into play. So they often have common names, and those have sort of been incorporated in as the IUPAC names as well. So we know about benzene, which is sort of the simplest derivative of an aromatic compound. It's the most common one. But in many cases, we have some substituent on the benzene, or maybe more than one. So we could have an X, maybe we could also have a Y, etc. So what I'm going to do is teach you guys how to name when there's more than one thing on there. What I want you to do is read section 4.6 in your book about naming, because that will sort of help supplement this video. And I want you to be familiar with the first set of aromatic compounds and derivatives that are right under section 4.6. Those are some common names that you'll come across. So as an example, when we have a benzene ring and it has a methoxy group on it like this, the common name for that is anisole, and it's also just what everyone calls it. So it's kind of the IUPAC name and the common name. We could have an anisole derivative that also has another substituent on it, and where that substituent is relative to my anisole is going to dictate how I name it. So when I only have two substituents, I use ortho, meta, or para to describe their relationship to one another. So for ortho, that's next door neighbors. So this position and this position are the ortho positions. The meta position is one away from my substituent, so this would be meta, and this would be meta, and the para position is opposite of my substituent. So instead of using numbering like 1, 2, 1, 3, 1, 4, which you can also use, we can use the ortho and meta and para nomenclature, which is very common in aromatic derivatives. So if we looked at this anisole derivative again, and let's say we have a chloro, and we put that chloro on there, that chloro is in the meta position relative to my anisole. So I could say M for meta, chloro, anisole. So the M tells me the relationship between those two substituents on the benzene ring. Anisole tells me that I have a benzene ring with this methoxy group on it. Meta tells me that there's one carbon in between the anisole methoxy group and the chloro group. If there are more than two substituents, I no longer use the ortho, meta, para terminology because that only works for two. So say that I had this guy, which is called acetophenone, and I'm going to add to my acetophenone two more methyl groups. So let's say that we have one here and one there. So we want to number this guy, and we want to do that so that we get the lowest number for our substituents as possible. So we'll start with our derivative, which is the acetophenone. So then 1, 2, 3, 4, 5, 6. So this is an acetophenone derivative. Specifically, this is 2,5-dimethyl acetophenone. So the 2 and the 5 tell us where those methyl groups are relative to my acyl group, this guy, on the acetophenone. Lastly, sometimes you'll see a benzene ring coming off as a substituent. If it is just the benzene ring coming straight off of what you're naming, then as a substituent it's actually called a phenyl group. If there is one carbon and then the benzene ring, this is called a benzyl group, and that has to do with this one carbon here. This is called the benzylic position. Next to a benzene ring, it has special reactivity, so as a substituent, CH2 benzene is a benzyl group. If it's just a straight benzene ring coming directly off, we call it a phenyl group.